Hello everybody, welcome to this demonstration wherein we're going to understand how resistance is affected by resistivity, length and area. So we have a very simple setup. We have a bulb and we have a switch and we can put in various load, and we have a 4 volt here. So let's look at that physically. How does it translate? Here's the bulb, it's connected to a source, a switch, and here is this this thing. It's nothing but just a connection, and here we are going to put in this load we're going to put in here, and the battery is here and the bulb is there, right? So to start with, we have 3 materials. We have brass, copper and iron. So I have 3 set up. So this is my copper. So copper has the least amount of resistivity, you can see that. And then you have brass. Now this brass has the next highest amount of resistivity, and then this is stainless steel, which is an alloy of iron. So that has a maximum resistivity of 0.97, right? Now one thing to remember is in all these 3, we have the length and the area exactly the same. So in this equation, your length and area are same and your resistivity is different. So let's see what happens. So first I'm going to put in my copper and switch on. So copper gives a certain amount of brightness. I'm going to remove this and put in the brass. You can see that the lightness would have reduced. So you see this brightness, and then the next one is the brightness have reduced a little bit, and finally the iron. So the brightness is the least. When you compare it with brass, it's quite significant. So the reason why this works the way it is can be explained by looking at the potential diagram. So you have the battery, which gives you energy of 4 volts, and as the current goes through this bulb, there is a drop in potential, and we don't know how much that is, and then there is further drop as the current goes through the resistance, right? So this is your V2 and this is your V1, the potential drop. So or let's name it V bulb and V load. So your V bulb plus V load is equal to 4 volts. Now if your load, this potential drop is proportional to the resistivity of the material, because in the load, if your resistivity is high, your resistance is high, that means your energy loss is high. And we know that the resistivity for copper is the least, and resistivity of the brass is greater than that, and resistivity of your iron or steel is greater than resistivity of the brass. So you have, since the steel has maximum resistivity, the drop is very high. So this quantity is high. So because of that quantity is high, this quantity will reduce. So that is why the loss against this load in steel is very high, because resistivity is high and your bulb is dim. As in copper, this loss is very less. That means that this loss is, so if I could draw this diagram for both copper, so it will look like this. For copper, it will look like this. The loss is very less. So this is a loss over the load, and the voltage across bulb is high. And for, in case of, this is for copper. In case of steel, this would be the story, that your bulb, the loss against your load wire would be very high. So your bulb, the potential difference is less. So this is dim and this is bright.